Hi, if you've taken AWS practice exams, you've probably seen questions like this. A company's web application experiences variable traffic and needs to scale automatically. User session data must persist across multiple servers. The architecture should minimize operational overhead. Which solution meets these requirements? Pause here if you want to try it yourself. I will say the answer in 5 seconds. The answer is B, Elasticache, but here's what makes this question brilliant. It's testing 3 architectural patterns simultaneously. Scale automatically, that's testing stateless architecture. Persist across servers, that's testing decoupling of state. And minimize overhead, that's testing managed services versus self-managed infrastructure. Most people study AWS services in isolation. RDS like this, Lambda does that. But the exam doesn't work this way. The exam tests whether you understand the mental models behind cloud architecture. In the next few minutes, I'm going to show you the 6 patterns that appear in over 60% of scenario questions. By the end, you'll recognize these patterns in seconds, not minutes. And if you already know some of these, I've added timestamps in the description so you can jump straight to what you need. Let's start with the foundation. Think of stateful versus stateless like 2 different restaurants. In a stateful restaurant, your waiter remembers your name, your order, your dietary restrictions. Every time you come back, you don't have to explain everything again, unless you go to a different stateful restaurant. In AWS terms, a stateful server stores information about you in its local memory or on disk. If that server goes down, you get routed to a different server. Your session is gone. A stateless server, it doesn't store anything about you. Every request contains everything the server needs to respond. Or there is a session data and session data lives on a shared external storage. Here's what the exam loves to test. Notice a pattern: managed services, external storage, no local state. Now here's the exam trigger phrase. If a question says need to scale horizontally or auto-scaling group, stateless is almost always the answer. Why? Because you can't reliably scale what remembers things locally. Quick exam scenario. You are building an e-commerce site. Where should you store the shopping cart? C. DynamoDB. It's external, managed, and stateless from server's perspective. If you chose D with sticky sessions, that's stateful and breaks when instance terminates. The exam will try and trick you with this constantly. Key takeaway: stateless scales, stateful doesn't. Store state externally. DynamoDB Elasticache S3. Moving on. Synchronous is like a phone call. You dial, you wait, the other person picks up, you talk, you hang up. You can't do anything else until the call is done. Asynchronous is like texting. You send a message and immediately go to other things. The response comes whenever it comes. In AWS, synchronous means the caller waits for a response. API gateway calls Lambda, waits for it to finish, then returns the result to the user. Asynchronous, fire and forget. S3 triggers a Lambda function when a file uploads. S3 doesn't wait around for a Lambda to finish. It immediately confirms the upload and moves on. The exam loves testing these keywords. Synchronous signals. Real-time response required. User must see immediate result. API returns data to client. Request response pattern. Asynchronous signals. Process in the background can tolerate delays. Event-driven. Notification after completion. Here's a critical exam detail many people miss. Lambda has both invocation types. If the exam asks about reducing API gateway timeout errors when calling Lambda, switch to asynchronous invocation or put a queue in between. Exam scenario time. A photo processing service takes 30 seconds per image, but users upload via a web form. What do? Don't make the web request wait 30 seconds, that's synchronous and terrible UX. Instead, user uploads to S3. S3 event triggers Lambda asynchronously. Lambda processes the image, writes result to DynamoDB, optionally sends SNS notification when done. Asynchronous all the way. Imagine two services connected by a chain. If service B goes down, service A can't function because it's directly calling B. That's tight coupling. Now imagine there's a mailbox between them. Service A drops messages in the mailbox and walks away. Service B picks them up whenever it's ready. If B crashes, the messages pile up safely in the mailbox until B recovers. That's loose coupling. In AWS, tight coupling looks like Lambda A directly invoking Lambda B. If Lambda B fails, Lambda A gets an error immediately and has to handle it. Loose coupling inserts a queue or a topic in between. Lambda A sends a message to SQS and forgets about it. Lambda B polls SQS whenever it's healthy. If B is down for 10 minutes, no problem. The messages wait in the queue for up to 14 days. The exam tests this constantly. Watch for these phrases. Tight coupling red flags are these. Services are dependent on each other. Direct synchronous calls between services. And loose coupling solutions. Decouple the services, handle failures gracefully, process messages independently. Here are your loose coupling tools: SQS, SNS, and EventBridge. They help decouple different services and make their lifecycle independent. Drop a comment if you want me to explain when we must choose SQS, SNS, or EventBridge. A real exam question pattern. A microservice architecture has service A calling service B, which calls service C. When service C experiences high load, the entire system becomes unresponsive. How do you fix this? C. Queues break the synchronous dependency chain. Service A puts messages in Q1, service B processes from Q1 and puts results in Q2. Service C processes from Q2 at its own pace. If C slows down, messages queue up instead of timing out. Pro tip: if the question mentions resilience, fault tolerance, or graceful degradation, think loose coupling. Moving on to where this really shines: event-driven architecture. Event-driven architecture is like a doorbell. When someone presses it, multiple things can happen. The chime rings, your phone sends an alert, the security camera starts recording, the smart lock logs the timestamp. One event, multiple reactions, and none of them directly calls each other. In AWS, services react to events instead of directly calling each other. An event is just something that has happened. File uploaded, database record changed, message arrived, scheduled time reached. Here's the pattern that the exam loves: the fan out. One event triggers multiple independent processes. User uploads an image to S3. S3 sends an event to SNS. SNS fans out to 3 Lambda functions. One creates a thumbnail, one runs facial recognition, one updates the database. They all run in parallel independently. If the thumbnail Lambda fails, the other 2 still succeed. That's the beauty of event-driven, decoupled, parallel, resilient. A company uploads product images to S3 and needs to generate thumbnails, extract metadata, update Elasticsearch index, and send notifications to the mobile app. Which architecture provides the most decoupled solution? C. SNS fanout. Each Lambda is independent, subscribes to the same SNS topic, and processes events at its own pace. If you need to add a 5th task later, just add another Lambda subscription. No changes to existing code. EventBridge deserves special attention because the exam is obsessed with it lately. EventBridge is like an intelligent post office. It receives events from multiple sources, matches them against patterns, and routes them to the right destinations. For example, this pattern says, only send me the events from EC2 when instances are terminated. EventBridge filters everything else out. This is perfect for scenarios like send Slack notifications when production instances terminate unexpectedly. Exam scenario: multiple AWS accounts need to react to events from a central account. Which service? EventBridge. It's the only one that natively supports cross-account event routing and fine-grained filtering. One more practical exam topic: dead letter queues or DLQs. When event processing fails repeatedly, where do all these events go? Without the dead letter queue, they are lost forever. With the DLQ, failed events get sent to a separate SQS queue where you can inspect them, debug, and retry manually. If a question asks about ensuring no events are lost or troubleshooting failed processing, configure a dead letter queue. Event-driven architecture is the exam's favorite pattern because it combines stateless, asynchronous, and loosely coupled all at once. Next up, how to structure entire applications. Monolithic architecture is like one massive building with all departments inside. Sales, engineering, HR, everyone under one roof. To change anything, you have to coordinate with the entire building. Microservices are like a campus of small buildings. Each department has its own building. Sales can renovate without bothering engineering. One building can burn down without affecting the others. The exam has a heavy bias toward microservices, especially serverless microservices with Lambda. If you see any of these phrases, the answer involves breaking apart services, usually with Lambda functions, API gateway, or separate databases per service. Let's review an e-commerce microservice example. A website might have user service with DynamoDB, order service with RDS, payment service with an external API. Notice a pattern here. Each service has its own database. This is called database per service pattern, and the exam likes it. Why? Because it prevents tight coupling through shared databases. Shared database is a monolithic anti-pattern. If the user service changes its schema, it can break the order service. Keep databases isolated. Exam question. A company's development teams are blocked waiting for database changes from other teams. How can they achieve their autonomy? B. Separate databases mean teams don't block each other. Now you might be thinking, but don't microservices need to share data sometimes? Yes, and that's what events and APIs are for. Order service publishes order-created event. Inventory service subscribes and updates its own database. Loose coupling through events, not shared databases. Quick summary. Exam favors microservices for flexibility and scaling. If it mentions team independence or separate deployment cycles, think microservices with isolated data stores. Orchestration is like symphony orchestra. There's a conductor who tells each musician when to play. The conductor has the full score and coordinates everything. Choreography is like a dance floor. Everyone hears the music and reacts independently. No central controller. Each dancer follows their own routine. In AWS, orchestration is step functions. It has the complete workflow, handles retries, makes decisions. Step functions knows the entire flow, processes payment. If it succeeds, go here. If it fails, go there. Retry 3 times with exponential backoff. It's central brain. Choreography is EventBridge. Services listen to events and react independently. There's no workflow definition. Each service knows its own job. Here's how to decide on the exam. If the question mentions complex workflows, retries and error handling, conditional branching, long-running processes, or parallel execution, you're looking at a step function scenario. Step functions excels at orchestrating multi-step workflows where you need centralized control. On the other hand, if the question talks about multiple services reacting to the same event, loose coupling, adding new features without changing existing services, or filtering events based on patterns, That's EventBridge's territory. EventBridge is your choreography solution where services independently subscribe to events and react on their own terms, making it perfect for scenarios where you want maximum decoupling and the flexibility to add new event subscribers without touching your existing architecture. Exam scenario. An e-commerce order goes through payment processing, inventory check, shipping label generation, and email confirmation. Each step depends on the previous one. If any step fails, send to customer service queue. Which service? C. Step functions. That is a sequential flow with error handling and continuous logic. Perfect orchestration use case. Difference scenario. When a new user signs up, you need to send a welcome email, create a CRM record, trigger onboarding automation, and update analytics. These can all happen independently. Which service? EventBridge Choreography. Use a signed-up event for independent subscribers. If you later want to add a fifth action like schedule follow-up call, just add another subscriber, no changes to existing services. Both patterns appear regularly on the exam. Step functions for workflows with logic and dependencies. EventBridge for independent reactions to events. Let's wrap it up with your exam strategy. Alright, you now understand the 6 architectural patterns that drive most of AWS exam questions. Here's how to use this on the test day. The exam has a formula. Scenario questions follow this template. A company needs to business goal. The solution must be a non-functional requirement, which architecture provides. Here must insert quality attribute. And here's your attack strategy. First, identify the primary pattern being tested. Is this about state coupling or communication style? Second, eliminate answers that violate the pattern. Third, choose the most managed serverless loosely coupled option. The exam has a strong bias there. The exam will make these wrong answers look tempting. They technically work but violate best practices. Always choose the option that's more decoupled, more managed, more stateless. These patterns form the foundation. Once you've got this down, the services are just tools to implement these patterns. In my next video, I'm going to deep dive into building event-driven applications with Lambda, all the integration patterns, error handling, and exam tricks. If this helps, subscribe for more AWS certification content. Drop a comment with which pattern you found most useful. And if you are studying for the Developer Associate, I've got a full exam prep playlist linked below. Good luck on the exam, and I'll see you in the next one.